Welcome to another episode of Dr. Lanny Health. This one's going to deal with the art and the science of discovery. It's been said that there's nothing new under the sun. That was been written years ago. But on the other hand, there's a lot yet to be discovered here. And that's what we're working at, is discovery. I'm Lanny Johnson. I'm an orthopedic surgeon. I have a long history of interest in cartilage healing and other aspects. I was one of the pioneers in arthroscopic surgery. I invented the motorized instruments that made arthroscopic surgical possible. And so today, though, I'd like to talk to you about procatechuic acid. I'd never heard of it. Yeah, I'll tell you in one of our other episodes how I came about it, but I need to discuss procatechuic acid. I will use the word PCA, the acronym, because procatechuic acid is hard to say. Procatechuic acid is not pronounced properly by me, nor is the spelling of it make it easy to pronounce it. So from here on, we're using PCA, which is the acronym for procatechuic acid. I came upon this about 20 years ago, this being the year 2025, and we'll deal with that in a different episode. But I need to tell you what procatechuic acid is. It is a nutraceutical. It's found throughout nature. It's within all the trees. It's in the soil. It's in the plants. It's in the ponds. It's in the rivers. It's everywhere in nature. In addition, it's very common to the human diet. It's found in almost all of the processed foods. Incidentally, it happens to be in Pepsi-Cola, happens to be in Coca-Cola. But it also is in white wine, and it's found in onion skins, and most all of the fruits or vegetables that you eat have procatechuic acid. In addition to the fact that it's a part of the human diet, it also is common to the human microbiome of the large bowel, because procatechuic acid, or PCA, is made by the bacteria in the human bowel. So PCA is everywhere. So when I learned about it, I wondered what possible applications it would have to health, since it was so much a part of nature and so much a part of humanity and our normal microbiome. So having made those discoveries, I found out these things about PCA. PCA happens to be a non-toxic, non-allergenic, and non-mutagenic, means it doesn't cause cancer. In fact, in the literature, there's scientific papers that say that it actually could be therapeutic for cancer. So although PCA is new to me and probably new to you, it was first in the medical literature in 1890. Why no one has really looked at that, I have no idea. In addition, there are 1,000 papers published about procatechuic acid, or PCA, most of which are very, very good, but they're from the standpoint of something done in the lab or something done with animals. And so we needed to find out what happens with PCA when it's in a human. So we have a number of human applications going on and studying, mainly from the orthopedic standpoint of how we might control infections in orthopedics. And so we did a study on 60 humans, men and women, age 55 to 65. It was a randomized, prospective, double-blinded study to learn how does PCA affect all the different normal blood tests. And what we learned is that the literature said that PCA would cause hypoglycemia, or reduce the blood sugar. Our studies in humans showed that it had no effect on the blood sugar. It had no effect on the studies done on postprandial blood sugar. The literature also said that it would tend to affect the clotting time, and the prothrombin time was unchanged in our study. The literature said that it would reduce blood cholesterol, when in fact what happened is it slightly elevated the blood cholesterol, which means that when we do our human studies, that's something that ought to be validated. In addition, we wanted to know how it would affect blood count, how it would affect what's called the sedimentation rate, how it would affect the C-reactive protein, and we found out that there was nothing abnormal in those tests, which gave us a good basic for the clinical studies that we're going to do. In addition, the literature said that there's a positive effect upon the immunity of animals. And so in humans, there's a way to do a test that's called a CXCL9, which is a test to show whether the person has had a positive effect to their immunity from taking a treatment. And we found that in our studies on these humans that there was an increase in the biomarker for immunity.